All right, so we're on notes 3-5 today, curve sketching. This is finally when we get away from analytic analysis, when we get more into the graphical analysis side. So this is very, like, you know how geometry is one of those skills where you kind of like look and play around with things in your head. This is that type of half of the unit. You're playing around with stuff in your head. Okay, so today's date is Monday, October 19th, 2020. Curve sketching, yes, our objective today is to, Chris, go. There it is, okay. So let's practice graphing these things. X squared, everyone practice graphing that. What does that look like? Do it on your own first. What does X squared look like? So again, yeah, the easiest way to make this is to make a table of X and Y values if we forgot. Try plugging in 0. When I don't move left or right, what is my height? 0 squared is 0. When I plug in 1, 1 squared is 1. When I plug in -1, -1 squared is 1. So let's graph these points so far. So I have that point. Let me zoom in here so you can see a little bit better. I have that point. I have that point. What else do I have? Let's try 2. When I plug in 2, 2 squared turns into 4. And similarly, -2 is also going to turn into 4. So if I go left, I go up 4, 1, 2, 3, 4, 1, 2, 3, 4. And at this point, you can probably see you're going to go off the graph. If I go to 3, I should go up to 9. But this graph only goes up to 5. So I can't really graph anymore. I can kind of sketch what's going to go on, though. So it's going to be this parabola shape. It's not a sharp V. It's not a sharp corner at the bottom. It's a nice, gentle curve. And then you can put arrows at the very top to let yourself know. Yeah, it does go on forever and ever. To the right forever, to the left forever, and up forever, but not down forever. All right, so on each and every one of these, I want to talk about what they're called. So if I just saw this shape of a graph, does anyone know what that shape is called? I said it once already. Shape. Or what type of function does the shape represent? You remember back to algebra 1? It's called a quadratic. So let's write down, this is called quadratic. Quadratic just meaning that the highest degree term is 2. Yeah, and then what type of quadratic? Is it a positive quadratic or is it a negative quadratic? Again, positive quadratic is a smiley face, negative quadratic is a rainbow. And since you see me going positive like that, we say it's a positive quadratic. So I'll put a plus, maybe a circle around it. Say it's a positive quadratic. And knowing that it's a positive or negative cubic or positive or negative linear, those are super important because if I have a positive quadratic and I take the derivative, it's also going to be positive. If I take the derivative again, it's still going to be positive. I'm always going to be positive until the very end when I get to 0. Okay, so analytically, let's go ahead and do this. Algebraically, if I have x squared and I take the derivative, I get what, Fiona? Say it again? 2x, yeah. 2x. So everyone now graph 2x. Again, it's like 2x plus 0, right? So the y-intercept should still be 0. I'm going to come around and see that we all know how to remember how to graph 2x. Okay, so yeah, so it goes through the origin. It goes right 1 up 2, right 1 up 2, and then alternatively left 1 down 2, left 1 down 2, and there is our slope. And because it's a line, I can go ahead and use my line tool and say, go like that. There it is. What type of function is this? Linear, yeah. And is it a positive linear or a negative linear? Does it have a positive slope or a negative slope? Positive. So we'll come down here and say that is a positive linear. Perfect. Let's continue going on. I forgot my arrows that say it goes on forever and ever to make it a perfect graph. Okay, let's take the derivative again. The derivative of 2x. Andrea, go. 2. Everyone graph 2. Graph y equals 2. And hopefully you're graphing the y-intercept of 2. And because no matter what value I choose for x, it's always going to have a height of 2. always has a height of 2, always has a height of 2, always has a height of 2. This is just going to be a horizontal line here through 2. Okay, a little bit harder of a function to remember the name of, but let's see if anyone can do it. What type of function is this called? If you say linear, you're correct, but it's more specifically this other function. Starts with a C. Anyone? Yeah, there it is. Yeah, constant. And what type of constant? Is it a positive constant or a negative constant? So yeah, so it's above the x-axis, so it's this positive constant. And then if I take the derivative again, Teflon, derivative of 2 is, say it louder. 0, yeah. And everyone graph 0. It's another graph that looks like the same, except now it's down here on the x-axis. It is the x-axis. Y equals 0 is the x-axis. And then I can come down here, and it's a constant again. It's not even a positive or negative. It's just a constant. This constant 0 function. So let's say constant 0, I guess. So having these equations is helpful, but what we need to be thinking about in the future is we're going to be given this graph of a quadratic, only the graph, not the equation, and you need to predict what the derivative is going to look like. You need to predict what the derivative, keep going farther and farther in time. And I consider this like a baby step because this is easy. A quadratic is easy. I'm eventually be giving you something like x to the power of 5, and you'll be able to tell me what that looks like graphically. So we're getting ready for that, prepping. Let's move down here to example number 1. Oh, I forgot. Sorry, there's some things I need to talk about on these graphs up here. On a graph of f, let's go ahead and find where this function has, where it's increasing, where it's decreasing, all those previous definitions. I need to get that review kicked in because I don't think there's too much. There is a backside, but these go kind of quick. F decreasing, let's do that one first. What is the definition of f decreasing? Chris, f decreasing. Yep, f prime. So f decreasing is where f prime is less than 0. Chris, on a graph of f, what is f prime? Is it height, slope, or concavity? Slope. And then Chris, where is slope less than 0? Say it louder. So again, if I were to draw any point on this line, that tangent line is negative there. The slope of the tangent is negative. Over here, the slope of the tangent is positive. Therefore, it's between what and what, or negative infinity 0. Yeah, so we can say everything over here on the left-hand side of the 0 is f decreasing. Obviously, everything on the right-hand side is f increasing. What about our CVs? Fiona, what's the definition of FCV? What's 0? F prime or F double prime? Yep, F prime is 0, or D and E. Ran out of room there. Where are, oh yeah, sorry. Next question is, on a graph of F, what is F prime? Slope, and then where is slope 0 or D and E? There it is. So everyone label this point down here. This point right here is an FCV. Andrea, give me the definition of F relative extrema. Yep, relative extrema is where we have F prime. I'm running out of room. I can't right here. Sign change. On a graph of F, what is F prime? And then where do you have a slope sign change? Okay. F relative extrema. So relative extrema. And then Teflon, give me the definition of both F min, F relative max. Negative into a positive, and then the other one is positive to a negative, obviously. So is this point right here a minimum or a maximum? Yes, why? Yeah, exactly. The slope was a negative, then it turned into a positive. So we can come down here and say that's an F minimum. And then we haven't even talked about the second derivative test now. So let's come back to Chris. Chris, what's the definition of F concave up? Give me F concave down. Is it F prime or F double prime? F double prime, and it's either going to be bigger or less than 0, right? So F concave up is greater than 0. And still on Chris, on a graph of F, what is F double prime? Is it height, slope, or concavity? On a graph of F, yep. It is concavity. So therefore, where is F concave up on this graph of F? At 0, yeah, and more, everywhere. This is concave up everywhere. There it is. And finally, inflection points. If you want to give me the definition of F inflection point. F double prime sign change, exactly. And on a graph of F, what is F double prime? And where does a concavity have a sign change? Nowhere. So there's no inflection point. There it is. These are going to be consistent over and over again. That means that I'm increasing on the right-hand side of 0. I'm decreasing on the left-hand side of 0. My CV, relative extremum, and F minimum all happened at that same point. These are consistent for each of these graphs. I can label them. I can copy and paste this over and over and over again. It's kind of hard to tell on a graph of F double prime what's happening with F prime because we don't know how to go backwards yet. But I really want to focus on these two graphs, F and F prime. On F double prime, I can find concavity, but that's about it, and inflection points. So let's do this example 1. New function, G. There's my graph of G. First of all, what type of function is it? Is it quadratic, cubic, quartic, linear, constant? What do we have? Let's give it to Andrea. Linear, and is it positive or negative linear? Negative. It's a negative linear, yeah. The ball rolls downhill, right? Yeah, so everyone label this graph as a negative linear function. Okay, and the next question that I have for Teflon is, what do you think the graph, actually let's do it for everyone. Everyone right now, predict what the graph of G prime is gonna look like. Predict in your head, and if you're confident, write it down. I'm about to draw the graph of G prime over here. What is the graph of G prime gonna look like? What do you mean positive? Everyone try sketching now. If you need to erase it, that's okay. Everyone sketch it right now. And Teflon, tell me what you wrote. Down to the left, so down like there. Across through the origin, so right there. Okay, close. But notice that the pattern up here, we moved from a linear to a constant. We have a linear also, so when I take the derivative, it should also move to a constant. So it should be some sort of horizontal line. The question is, where? Where should I draw that horizontal line? Should I draw it right there? Exactly, yeah. It needs to be somewhere below the x-axis because it's negative. So that's the correct answer. Everyone label it too. That's called a negative what, Chris? Negative constant, there it is. So we all know that when I take the derivative of a negative linear, it turns into a negative constant. Let's try another one. This thing. Andrea, what's this one called? Yep, and is it positive or negative quadratic? Yeah, positive quadratic, everyone label it. Let's take a look at some key values here because it'll help us with our next graph. Fiona, do you see any since it's a graph of h, do you see any minimums? Do you see any increasing, decreasing, anything like that that you can analyze for this graph of h? What do you see? Let's call this point A. So we'll say that we'll have f decreasing over there, therefore f increasing over here. Yeah, let's see if that's enough information to help us. We want to do as little as possible to see if we can make a linear function. When we make our linear function, I kind of gave it away. So still on Fiona, I told you it's going to be a linear function. Is it positive or negative linear? Yep, it has to keep the sign. So positive linear. And A is going to be important. I'll relabel A right here. What's going to happen with our linear function, Fiona? Say it louder, just through your mask. Go through A, and since it's positive, it's going to go like that. Yeah, so everyone go ahead and graph your line. Positive line that goes through A. And it doesn't matter what slope. Is it a crazy big slope? Is it a small slope? It just needs to be a positive slope through A. And let's make sure that makes sense. So f increasing over here on the right-hand side means that f prime, or I guess I should say h prime, is above 0. H prime on a graph of h prime is height. Height is above 0. Boom, it works out. And again, you could have made a different analysis. Maybe instead of doing f decreasing, f increasing, you ignored that and only did, this is an f minimum. You say, hey, at this point right here, I have an f minimum. An f minimum, by definition, Teflon does what? What goes from negative to positive? F prime or f double prime? Yeah, I guess I should really be saying h prime, shouldn't I? Because it's the graph of h. Yeah, but you're right. It's the first derivative, right? So I have h prime decreasing. This is an h prime minimum, h prime increasing. And as you said, yeah, h prime minimum, I should say, why am I saying h prime minimum? I should say h minimum. H minimum, as you said, h prime goes from a negative to a positive. That means over here, I should have a h prime negative to a positive, h prime negative to a positive. And on a graph of h prime, what is h prime, Chris? Height. And then height was negative down here, is below the x-axis, and it was positive up here. So it works out. Again, you can use any of your tools that I've been giving you to try to make this work, and try to use as few as possible. So decreasing and increasing, that was perfect. Let's move on to example number 3. Ooh, we haven't learned the name for this one, but you might have remembered from previous years. Does anyone know what this one is called? Volunteer? This is called a cubic. But the hard part is it a positive cubic or a negative cubic? So the way to remember this, if everyone can stand up really quickly, you're gonna get some arms moving, get some movement in the day. This is your PE class, right? So can everyone pretend that your arms are like the wings of an airplane, I guess? Go ahead and make a positive linear slope. Face the front of the board so everyone has the same slope. Positive linear, what does that look like? Like this. Your right arm should be up, your left arm should be down. That's a positive linear. Now make negative linear. Notice the end behavior. The end behavior are the tips of your fingers. When I have a negative linear function, my left hand is up, my right hand is down. The same thing happens for a cubic. A cubic will have a negative when the left is up and the right is down. So you guys go ahead and make the cubic. I mean, you can make like curvy things, but I only care about the end behavior. This cubic looks like this. Therefore, is it negative or positive cubic? There it is. Okay, you can sit down. This is a negative cubic. Simplify it down and pretend that you only look at the end points. So the way that I can do this for my notes is I can make some endpoints here at the very top up here, at the very bottom down here. And if I connect that with a line, that line has a negative slope, therefore it's a negative cubic. All right, so I need to analyze a few things. This is a graph of J, so you're gonna say J relative extrema, J decreasing, J increasing. So in this graph of J, what do you want to analyze to try to create a new graph? And this is volunteer basis. What do you notice? And there's a bunch of things you can analyze. Try to do as few as possible. Or I guess if you want to go overboard, you can go as many as possible, and you can see really how it relates to the next graph. Okay, well, I'll give you a hint. Mr. Sandell's personal favorite is to find minimum and maximums, because you can just tell. It's like a kindergarten question, like, what's a lowish part of that graph? And oh, this is a lowish part of that graph. That's called a minimum. What's a highish part of that graph? Okay, that's highest right there. That's a maximum. They're really easy to see on a normal graph of J, unless you take J prime or anything like that, right? On a graph of J. So I'm going to go ahead and label those in red. Right there, that's a J minimum. Up here, that's a J maximum. I like them because they're really easy to spot. Okay, and then I have to go back to the definition: J minimum, J maximum. Fiona, what's a J minimum? Yeah, there it is. And so we'll say J prime negative to positive. And therefore, Andrea, J maximum is J prime positive to a negative. Okay, so I'm going to go ahead and make those points. I'm going to call this coordinate here. Maybe I'll do it in black so I'm not confusing myself. This coordinate right here, I'm going to call it A. That x coordinate is A. This x coordinate over here is B. So let's go ahead and redraw A, redraw B. There's A and B. So on a graph of J prime, what is J prime, Teflon? On a graph of J prime, what is J prime? Is it height, slope, or concavity? Height. Okay, so you're saying that over here at the coordinate A should have a height that goes from a negative to a positive. So I'm going to go ahead and sketch. I have a height that goes from a negative to a positive. That's all I know. I'm going to sketch in the graph later. And then what should I sketch at B, Teflon? Yeah, a positive to a negative. So something that starts up and then goes down. Okay. I don't know if I have enough here. Oh yeah, so this is helpful too. How many bends do you see in your graph? Up here, we saw one bend. It changed direction once, right? One bend. So if you have one, I'm going to call those bends. This is not very mathematically correct. I could call it a more mathematically correct is going to be too confusing. So I'm just going to say one bend means it's something x squared. If I have 0 bends, maybe I should put that above that so that I'm consistent. If I have 0 bends, that's x to the power of 1. If I have 2 bends, it's going to be x to the power of what? Chris, x to the power of 3. If I have 3 bends, Fiona, I'm going to have x to the power of 4, and et cetera, et cetera. So just look at the number of bends, add 1 to it, and that's going to be the power that you're talking about. Which means if I have a cubic, that is something that's x to the power of, well, I have 2 bends, add 1. So it's really talking about x to the power of 3. That's a cubic. If I take the derivative of x to the power of 3, I get, 3 comes down in front, and I get what, Andrea? 3x squared. Something with an x squared in it. That means I have an x squared over here. I don't care what number is out front. I just know that it's an x squared, which Andrea is called a quadratic. And is it a negative or a positive quadratic? It's going to say the same sign. There it is, yeah. So negative quadratic. Everyone write it down. This is a negative quadratic. And as you all know, quadratic is just a parabola. It's that horseshoe. It's a rainbow. It's a smiley face. It's one of those. Well, if it's going to be a rainbow or a smiley face, I know a negative is going to be a rainbow. It's going to be pointing down. And I see from Teflon's analysis, I know where that happens. It's going to go down through A and through B. And I just kind of maybe undo those lines a little bit. Those were helpful for now, but now that I have more analysis out of the way, I can say, okay, well, I know that I go through that way. I can go ahead and say my quadratic is a parabola that looks like this. I could do better, but there's my negative quadratic, and it has to go through those A and B. So we're really playing Sherlock Holmes here. Our detective work has shown a bunch of information. We're putting it all together to make that graph. They're kind of fun, solving these puzzles. All right, here's another puzzle. Okay, well, I'm starting. Oh, whoa, what's going on here? I'm not starting with a graph of K. I'm starting with K prime now. A little bit harder. Okay, so on a graph of K prime, what is K prime, Andre? Height. Okay, so what do you want to analyze? You want to do a K prime equal to 0? Do you want to do a K prime that goes from a positive to a negative? Some sort of definition that you know about K prime. What do you want to use? Okay, so K prime positive to negative. Let's go ahead and call these points. Let's do in black here. I'm going to call this point A, this point right here in between B, and this point over here, C. So where does K prime go from positive to a negative, Andrea? Which one? No. So K prime again is height. The height goes positive, and then the height turns into a negative. A goes from a negative down here to a positive, which is the reverse, which you can use. So we can come down here and say, over here at A, this is a K prime positive to a negative, which means, Andre, where's a K prime negative to a positive? C, yeah. So over here at C, that's a K prime negative to a positive. I think just because it would help us to be less confusing, on a graph of K prime is height. We should label that. So K prime is height. I should have been doing that for all these previous problems, like example 3. I should have said J prime is slope. And on a graph of J prime is height. So on a graph of K, I can come back here and say, I'm still using the same definition, K prime. K prime is no longer height, Teflon, it's what? On a graph of K, what is K prime? K prime is slope. All right. So now this is going to be a volunteer question. How can we use Andrea's analysis that K prime went from a positive to a negative at A, K prime went from a negative to a positive at C, to talk about what's happening with the slope? Let's do a more pointed question. Chris, what is this definition of K prime positive to a negative? That is a K minimum, K maximum, K increasing, K decreasing. It's something with K, right? It's K. No. Decreasing would be just less than 0. Take another guess. Look at your speech sheet. What goes from a positive to a negative? A maximum, yeah. So we'll say this is a K max. Therefore, the other one, Chris, is a K min. There it is. So I should have some sort of maximum over here at A. So let me go ahead and relabel A, B, and C. What do you mean? The height from A went to, oh, I wrote those backwards, didn't I? Yeah, that's a teacher mistake. Can you log that credit? If anyone else got that before I did, please log it too. I said it right. I just didn't write it down right. Yeah, and which means these are now wrong too, since they were based on incorrect information. Let's go ahead and fix that. Thank you, Fiona. Good catch. Otherwise, we would have gotten this wrong. All right, so this is a K prime negative to a positive. Yeah, we had this negative height down here, and then we went up to this positive height. This is k prime positive to a negative. And negative to a positive is a minimum. Positive to a negative is a maximum. All right, so at this x coordinate A, I should have a minimum. So you can make that whatever you want. I'm going to go ahead and say, ooh, we have to be careful though. Is the minimum going to be here or is it going to be here? Do I ever cross this axis? And it's hard to tell. So let's just go ahead and take a guess until we're proven wrong otherwise. Let's just go ahead and say I have a minimum there. I have a maximum there. What's happening here at B? Something interesting is happening at B. It looks like I have this maximum, but this is a maximum on K prime. So who can tell me what's going on here at this point B? What is this thing? At some important point, you need to give me the definition of it though. And I think it would be helpful if we labeled, what is K double prime on a graph of K prime? K double prime is what, Andrea? Slope. And then Fiona, what's happening with the slope here at B? Yeah, the slope is 0. So I'll say K double prime here is equal to 0. And even more, I mean, that there's no definition that we have on our speech sheet that says K double prime equals 0 or F double prime is equal to 0. But we do have some definition that says K double prime sign change, which is happening here. The slope was positive, and then the slope turned into a negative. So it is a sign change. Fiona, what is K double prime sign change? Yeah, it's an inflection point. So it's a K inflection point. So I should have some sort of inflection point happening here at B. And again, an inflection point means it's a change of concavity. Well, since I'm talking about concavity, maybe we should analyze what is happening with the concavity between A and B and B and C. So between A and B, Teflon, what's happening with the concavity? What's happening with the slope of this graph of K prime? Here, give me the definition. What is concave up? K concave up. Flashcard definition is close. Double prime, yeah. So we'll say here is K double prime. Oops, that double prime looks weird. K double prime is greater than 0. On a graph of K prime, what is K double prime again? Is it height, slope, or concavity? On a graph of K prime, K double prime is slope. So you're saying where's slope greater than 0? Where's the slope positive? Well, the slope is positive there, but it's negative here. So it's always positive between negative infinity and B. Yeah, everything to the left of B. So everything to the left of B should be concave up. Everything to this side of our graph of K should be concave up. And we know that we have a minimum. I should have labeled it back here. This right here was a F, or I should say K. This is a K minimum. This is a K maximum. And we have this K inflection point happening here at B. And I know that I'm going to have K is concave up. So I can come over and say, this is K concave up on the left-hand side. And on the right-hand side, everything to the right of B, that's K concave down, because we had a negative slope on this graph of K prime. And slope, again, means K double prime. All right. And there's not much more that we can analyze here. I think we've done a ton of analysis. Try to sketch your graph of K then. We know that we have a minimum. We know that we have a maximum. What does it look like then? I'll let you guys take a stab at it first, and then I'll come back and show you what I would come up with. Yeah, and the other thing I should have said before you guys started was that, yeah, if I have the graph of K prime, that means I take the derivative. I should get one less of these, what I call them, bends. And I should have one more bend when I take the antiderivative when I go backwards here. So if I had one bend here, I should have two bends here. And I know one of the bends is right about there. I know the other bend is right about there. And I just need to connect the two, right? So if I, oh no, why does it do that? Let me scroll down and then back up. Does that fix it? There it goes. So I should have one of these bends down here. And then I should switch concavity and start being concave down right about, I need to do better. I think if I drew my graph, maybe my minimum farther down, it would be easier for me to graph. But it should be eventually coming back up here and then concave down. I obviously need to work on this, my graphing skills. And then this should be going up and up forever. But generally that is our answer. We should have two of those bends. We have a minimum, we have our maximum. Our inflection point did change there. I know it kind of looks like a line here, and that's because I could have drawn that better. Yeah, those are hard going backwards. Let's just do another one going forwards before we end. Example number 5, we have a graph of m. I'm trying to get to m prime. First, what type of function is this? Like x to what power, I guess? I have 1, 2, 3 bends. So Chris, it's x to the power of x to the power of 4, yeah. X to the power of 4 is called a quartic. That's what we have here. And ooh, here's a good question for Fiona. Is this going to be a positive or a negative quartic? Positive, you're correct. Why? So to give everyone else the answer, if I look over here at, what's a good one? This one, look at this quadratic. This quadratic has m behavior. If I was standing up, both my arms would be pointing up. Up means I'm positive, down means I'm negative. The same thing applies down here. This quartic, both of my m behaviors going up. So I'm a positive quartic. If it was both pointing down, it would be negative. In general, if you're looking at these graphs, pay attention to your right hand. Your right hand up or down will tell you if it's positive or negative. For example, up here on the graph of J, my right hand was pointing down, so it was negative. Up here in example 2, my right hand was pointing up, so it was positive. Down here in example number 5, my right hand is pointing up, so it's positive. Your right hand affects whether you're positive or negative. So we're going to come down here and say this is a positive quartic. And as a note, you don't need to know that it's a quartic. You do need to know it's x to the power of 4 somehow. But as a note, if you want to know what x to the power of 5 is, it's called a quintic. So you can use those words correctly. But yeah, we have this quartic function. Go ahead and make some sort of analysis in terms of what's happening with m prime and m double prime. Really, for this one, you just need m prime. So before I let you guys loose, what is m prime on a graph of m? Andre? M prime is slope. So look for something that's happening with the slopes of this graph. Maybe the slope goes from a positive to a negative to a positive. Maybe the slope is 0. There's no slopes that don't exist. There's no sharp corners or anything like that. Go ahead and make some analyses with the slope in terms of being equal to 0, switching signs from negative to a positive, and use that to help you graph m prime. And let me make some points here. So this point I'm going to call A. This point I'm going to call B. I guess I can call it 0, but I'm going to call B. And this point I'm going to call C. We should have those same exact A, B, and C copied over here. So this is going to be my A, B, and C. I want to see what you guys can come up with. All right, so the analysis that I would like to make is that over here at A, I have f prime, or I should say m prime. M prime is equal to 0. And not only is it equal to 0, it goes from a negative slope to a positive slope. So it's also an m prime negative to a positive. B prime, or sorry, at the x coordinate B, I have m prime going from a positive slope to a negative slope. So this is an m prime positive to a negative. That means that should be, wait, what am I? Yeah, m prime positive to a negative, that is a maximum. Down here, that's a minimum. Down here, that's a minimum. That means that's an m prime going from a negative slope to a positive slope. And man, we have 40 seconds left of class. That's not good. Okay, so how do we get over here? So that means on a graph of m prime is now height. which means the height should go from a negative to a positive at A. So the height should go from a negative to a positive. And then it should go from a positive to a negative through B. And then from a negative to a positive at C. And we're done. And just verifying, I had how many of these? 1, 2, 3 of these bends, and I have 1, 2 of these bends, which makes sense. I'm taking the derivative. I should get one less bend. This is a graph of x4. This should be a graph of x to the power of 3. Everything looks good. All right, that concludes the notes.